Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Magnetism and Matter. So any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos and in any other chapter of physics. If you have more difficulty, then also mention the name of that chapter in the comment section, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told a bar magnet is equivalent to. So we know that a bar magnet, North Pole and South Pole at its ends, that is equivalent to a solenoid which is carrying current, current carrying solenoid. Since why when it will carry some current, then also it will produce North Pole and South Pole at its ends, which is equivalent to a bar magnet. So should be so option one is the correct answer. So here it is told that the Curie-Weiss law is obeyed by iron at a temperature. So the Curie-Weiss law is given as the magnetic susceptibility chi, that is equal to given as C by T minus T naught, T minus Tc, where Tc is called as the Curie temperature. And so it gives the magnetic susceptibility of a ferromagnet in the paramagnetic zone. So here it gives the value of magnetic susceptibility chi, gives the value of magnetic susceptibility chi of a ferromagnetic substance, of material ferromagnetic material in the paramagnetic zone. The paramagnetic. So here Tc is called as the Curie temperature. Curie temperatures. So it is applicable. So it is applicable only for T greater than Tc. So it means when T is greater than Tc, then only the ferromagnet will show uh, paramagnetic behavior. So the rule is for T greater than Tc, for a temperature which is greater than the Curie temperature, the ferromagnet will behave as a paramagnet. The ferromagnetic substance or the ferromagnet behaves as a paramagnet. So now, so therefore, this is only called as the Curie-Weiss law. Curie-Weiss law. So it is applicable above the Curie temperature. So option 2 is the correct answer. And here it is told that a tangent galvanometer has a reduction factor of 1 ampere and it is placed with the plane of its coil perpendicular to the magnetic meridian. The deflection produced when a current of 1 ampere is passed through it is. So here, so we know that if the deflection in the galvanometer, the deflection in the tangent galvanometer is theta, then tan theta will be given as 1 by k, where k is called as the reduction factor. K is called as the reduction factor. So tan theta equals to I by K. I is the current that is passed through it. Tan theta equal to I by K. So here the reduction factor K has been given as 1 ampere and the current passed through it, that is also 1 ampere. So therefore tan theta will be equal to 1. So it means theta will be equal to 45 degree. So 45 degree of deflection will be produced in the tangent galvanometer. So option 2 is the correct answer. Then here it is told, among the following properties describing diamagnetism, identify the property that is wrongly stated. Uh, the first statement is told, diamagnetic material do not have permanent magnetic moment. The second statement is diamagnetism is explained in terms of electromagnetic induction. Third statement is diamagnetic materials have a small positive susceptibility. It means it is told that chi value is greater than 0, which is wrong. Since why diamagnetic substance means diamagnet, it means that it is weakly repelled by a magnet. It is weakly repelled in presence of a magnetic field, or it is weakly repelled by a magnet. So it means that it has got negative susceptibility. So it has got negative value of magnetic susceptibility. And chi means what? Chi, the magnetic susceptibility, it means it is the ratio of M and H, where M is the magnetization of the substance and H is the magnetic intensity. So the ratio of the magnetization divided by and the magnetic intensity is called as the magnetic susceptibility. Then fourth statement is the magnetic moment of individual electrons neutralize each other. So which is correct statement. So here A, B, and D are correct statements, but here it is asked the wrong statement. So it is option C. So it means option C is the wrong statement. So it is the correct answer. So option 3 is the correct answer. Okay, so then here it is told uh, torque, a torque acting on a magnetic dipole. Magnetic dipole means magnet, we can say. It is placed in a uniform magnetic field. It's placed in a uniform magnetic field, and the torque acting that is given as M cross B, where M is the magnetic moment, M is the magnetic moment of the magnetic di- dipole. M is the magnetic moment of the magnetic dipole, and B is the external value of the uniform magnetic field. B is the uniform magnetic field. And so here it is told the torque value is 0. It means now the magnitude of the torque that is given as M into B into sine theta, where theta is the angle which the magnetic dipole axis makes with the external magnetic field. So if that angle is theta, then the magnitude of the torque is MB sine theta. So here it is told the the torque will be 0 when the angle in between dipole axis and the magnetic field, that theta will be 0 degree or 180 degree. So if it is 0 or 180, then sine theta will become 0 only, and theta will be 0 only. So it means that the angle between the dipole axis and the magnetic field in this case will be 0. Option C is the correct answer. Then here it is told the horizontal component of the Earth's magnetic field at a place. So at a place, if the resultant magnetic field is B, so then we can take its two components. One is BV and one is BH. BH is the horizontal component of the Earth's magnetic field at that place. And the angle which the horizontal component of Earth's magnetic field makes with the net magnetic field at that place, that is called as the angle of dip or dip angle, or it is called as inclination. So the angle of dip is delta, suppose. So then B cos delta, that is equal to BH. So here it is told the horizontal component value is given as 3 into 10 power minus 5 Tesla. So then we have to find the resultant. We have to calculate the resultant magnetic field at that place. Therefore, B we can say that will be equal to BH by cos delta. Now here, the angle of dip at that place, the dip angle at that place, that is delta, it is given as 45 degrees. The cos delta will be cos 45 degree, which is 1 by root. So therefore, the resultant magnetic field, that is given as BH by cos delta. So BH is 3 into 10 power minus 5, and by cos delta, that is 1 by root. It will be 3 root 2 into 10 power minus 5 Tesla. So option B is the correct answer. Then here it is told the Curie temperatures of cobalt and iron is so the Curie temperature for cobalt that is 1400 Kelvin, and the Curie temperature for iron is 1000 Kelvin. 1000 Kelvin. Then if T equals to 1600, 1600 Kelvin. So here, so we have to find that at T equals to 1600 Kelvin, what is the ratio of the magnetic susceptibility of cobalt to the magnetic susceptibility of iron? So magnetic susceptibility of cobalt divided by magnetic susceptibility of iron. This value we have to find. So now we know that according to the Curie-Weiss law, Curie-Weiss law, the magnetic susceptibility of a ferromagnet. Since why here both this cobalt and iron, these both are ferromagnets. These are both ferromagnetic substances. So according to Curie-Weiss law, the magnetic susceptibility of a ferromagnet, uh, ferromagnet for any temperature which is greater than the Curie temperature, T greater than Tc, is given as chi equals to C by T minus T naught. But C is called the Curie's constant. No, sorry, T minus Tc. So therefore here we have to find the magnetic susceptibility of cobalt by magnetic susceptibility of iron at temperature T equal to 1600 Kelvin. So that will be equal to C by T minus Tc for cobalt divided by C by T minus Tc, which is the Curie temperature for iron. So this will be T minus Tc for iron, the Curie temperature for iron, by the temperature T, which is 1600 Kelvin, minus the Curie temperature for cobalt. So that will be 1600 minus Curie temperature for iron, that is 1000 Kelvin. Curie temp, so it will be divided by 1600 minus Curie temperature for cobalt, that is 1400 Kelvin. So this ratio you have to find. So this will be 600 divided by 200. So this will be equal to 3:1. So it is 3 by 1 actually. So it is 3. Ratio is 3. So option D is the correct answer. Yep. So hope all of you have understood the solutions of these questions. Uh, Based on the previous year KCET exam. Still, any doubts if you have, then please write that in the comments. We shall obviously clarify them. And please install our Sapiens education application also, since there we shall upload some important homework questions based on the previous year KCET exam, which shall be helpful for your exam. So thank you everyone